So, before we get into the examples of lesson 5.2 and everything you should know, I'm just going to quickly mention some things on the calculator that are really important and could change uh, any of your answers. So, first thing you should know is that when there's sine, cosine, or tangent, and you have the value of it, make sure that when you're multiplying it, you close the parentheses and you don't leave it opened like this, because this is going to give you the correct answer. However, if you do sine 62 times whatever you did before, it'll give you a wrong answer because it's multiplying 62 times 35 and then it's doing the sign. So you should be careful. Now, another thing you should know is that if it's given in radians, you need to also convert your calculator into radians. And if it's given into degrees, you should also convert it back to degrees. Like, for example, if you have sine 90 degrees, now to convert to radians and degrees first, you should know that you can do shift setup. So shift setup, and it'll give you the some settings here. Now it's going to be angle unit, so 2. It can be degree radians or gradient. Now you're going to either pick degree or radian. Now, if for example in the exam it gives us sine is equal to like 1.5 radians or whatever, then you can't do it. You have to do it like this, right? But if it gives it to us and if we take the degree version of it and we use it in radians, you know, like 65 degrees, and it's in the radian form, it'll give us a wrong answer. You have to use degrees. So angle unit, again, degree, and then you do sine 65. Very important stuff. Now, the final thing you should know is that to get secant, cosecant, and cotangent, it's the reciprocal, right? So there actually isn't a function for that on your calculator. So you're going to have to do 1 over sine and then whatever value. This will give you cosecant. And 1 over cosine will give us secant, and but you have to do like the fraction and then put the function. Now with that said, let's begin with the examples. So for this first example here, we're going to start with the simple stuff and then we'll get into the harder stuff later. So for now, we have this triangle here, right triangle. We have sides 2, 3, and hypotenuse, we don't know. So we don't know the hypotenuse. So we just use the Pythagorean theorem here. So c squared is equal to a squared plus b squared, going to be equal to c is going to be equal to radical 4 plus 9, which is going to be equal to radical 13. So now that we know that the hypotenuse is 13, so we can write here 13, let's find the 6 functions. So starting with sine, that sine is equal to, obviously, opposite over hypotenuse. So let's just quickly do it. This is 13. This is radical 13. So it's going to be 2 over radical 13. Now, we can't leave it like this because there's a radical in the denominator. So we multiply this by 13 here. And it's subjective, so you're going to have to show this. You're going to have to show your work here. It's going to be 2 radical 13 over 13. And this is your final answer. Now for cosine, it's going to be 3 over radical 13. No, same thing. It's going to be equal to 3 radical 13 over 13. Now finally tangent, going to be equal to 2 over 3. So opposite over adjacent, which is just 2 over 3. Now, we just find the reciprocals of each. So this is going to be, so for sine it's going to be cosecant. Theta is equal to hypotenuse, which is radical 13 over opposite. So we can just leave it like this now. So and then cosecant, reciprocal of this, So it's going to be radical 13 over 3. And then finally tangent or cotangent. Cotangent is going to be equal to 3 over 2. And those are the 6 functions. So for this next question, it asks us to use the Pythagorean theorem. So the exam is going to be in subjective, so if it tells us to use the Pythagorean theorem, then we should use the Pythagorean theorem to find the length of the missing side. Then find the exact value, so we can't use a calculator, we have to solve manually, of the 6 functions for the angle opposite to the shortest side. Now what does this mean? If we have a triangle here, draw a better one, and we have angle here, and the shortest side is x, the shortest side is 3, we have side 3, 4, and 5. And it says the angle opposite to the shortest side. So that means the angle is going to be opposite to the shortest side. It can't be here. The angle cannot be here. Here it's wrong. Because the shortest side is 4. So the angle should be here. Now knowing this, let us solve this question. So the missing side, we have the leg, we have the hypotenuse. So we're missing one side. So it's going to be c squared plus c squared is equal to a squared plus b squared. We have the hypotenuse, so 2 radical 21 squared to be equal to 5 radical 3 squared plus b squared. And then you can just solve this. 4 times 21 is going to be equal to 25 times 3 plus b squared is going to be equal to 84 equal to 75 plus b squared. And then 9 is equal to b squared. B is equal to 3. So the shortest side is going to be 3. It's going to be 3 inch. So you have 2 legs and 1 hypotenuse. So we can draw this triangle if you want. We have hypotenuse 2 radical 21 inch, leg 3, I guess we'll make it more accurate, 5 radical 3 inch, and then 3 inch here. Now, where would the angle be? The shortest side is here, so the angle should be opposite to it. Now we want to find all the 6 functions. So we can quickly do that. Sine theta is going to be equal to opposite over adjacent, so 3. So opposite over hypotenuse, so 3 over 2 radical 21. Now we can't leave 21 here, so I'm going to have to multiply it. So it's going to be 2 radical 21 times 2 radical 21. Now this will be equal to sine theta will be equal to 6 radical 21 over 84. And then after simplifying this, we can get radical 21 over 14. Now I won't solve all of them just for the sake of saving your time, and we'll get into the next question. Now this question, it asks us that given the value of one function, find the remaining 5. So we have tangent 4 over 7 here. So what we can do is that we know that tangent is equal to opposite over adjacent. So if we draw a little triangle here, we have 2 sides, so opposite over adjacent, hypotenuse. We have 4, which is the opposite, and 7, which is the adjacent. So we can simply substitute. So we have 4 here, 7 here. Now we can find the hypotenuse. We're using the Pythagorean theorem. So x squared is equal to 4 squared plus 7 squared. And then you'll get x is around 8. So 8. So now that we know all the values, we can find an acute angle. Now to find the acute angle, we should look at the tangent. It's opposite over adjacent, meaning that we can't take this side because the opposite is 7, and it's not 7 over 4. So we need to take this angle, because opposite 4 over 7. Now knowing this, we can find the other functions. So we'll just find sine. Sine is going to be equal to opposite over adjacent, so 4, opposite over hypotenuse, so 4 over 8. It's going to be equal to 1 over 2. So for the next question, it says use an appropriate Pythagorean identity. So use a Pythagorean identity. In the exam, we have to use it to find the indicated value. We can't use a different method. We have to use an identity. Now we have given here secant 37 over 35, and it wants us to find the tangent. So it wants us to find the tangent. So first thing we have to do every single time, especially in the exam, write the formula. So this will give you half the grade. Sine squared plus cosine squared give us 1. So can we use this? No, we have to use a different version. One where we have secant and we have tangent. Now, if you memorize it, then you already know there's one, but if you don't, then you can try it. Get lucky, maybe. Divide by cosine squared. Divide by cosine squared. Divide by cosine squared. And then you'll get tangent squared plus 1 equal to secant squared. Now, if you got unlucky and you tried sine first, then just, then it's going to be cosine the next time. But this will be the formula we'll use. Now, to solving, we simply substitute the value of secant. So on your calculator, you won't write secant theta equal 37 over 35. You're just going to write 37 over 35 as if it's going to as if it's a variable, x is equal to this. Because you're not finding the angle. So yeah. Okay, so let's find the tangent. So we do tangent squared plus 1 equal to secant squared. We substitute this for 37 over 35. So it'll be equal to 1 37 over 35 squared, right? So now what do? We can use a calculator here. So have 37 over 35 squared we get 1369. So just rewrite it here. Tangent squared plus 1 is going to be equal to 125. 1,225. Now that we have this value, we can minus 1 here, minus 1 here. Then we'll rewrite it again as tangent squared is equal to 2 fractions. 1339 minus 1,225, because we multiplied this by 1,000 on both sides, right? Times. So to give it common denominator, subtracting fractions. And then finally, we get tangent squared is equal to 1,339 minus 125, which is going to be equal to 144 over 1,225. Now we square root tangent, and then we'll get 12 over 35, and this will be the final answer. So for this question, it asks us, given the value of one function, find a cofunction of another angle with the same value. So how do we solve these types of questions? Well, we have two here, one with degrees and one radians. So we'll solve the degrees one first. It's pretty simple. The cofunction of tangent is cotangent, right? You should know this. and then you have 75 degrees. So what you should know is that 90 minus theta is going to be equal to, these two are now equal, right? These two are now complementary cofunctions, or complementary angles. 90 minus theta will be equal to 2 plus radical 3. So to make these complementary, you have to do 90 minus 75. So cotangent will be equal to 15 degrees, which is equal to 2 plus radical 3. And now you know that cotangent 15 is cofunction to tangent 75. And this will be the answer. Now for radians, it's a bit more tricky because it's not in degrees. We can convert it into degrees using the conversions 180 over pi, but that takes a longer time. So you should know that pi over 2 is equal to 90. So pi over 2 is equal to 90 degrees. And knowing this, that you can use the cofunction of cotangent, which is tangent. It's the opposite. Pi over 2 minus pi over 6, right? It's as if you're saying 90 minus whatever degree pi over 6 is equal to, which is equal to radical 3. And then you can just times 3 here, times 3 here. You get 3 pi over 6. Two pi over 6. Equal to radical 3. And then you can simplify this. It'll be tangent pi over 3 to radical 3. That'll be your answer. So for this next type of question, we have a lamppost that casts a shadow of 18 feet when the angle of elevation of the sun is 33.7 degrees. How high is the lamppost? So for these types of questions, which you will encounter at least one of them in the exam, you need to know how to sketch or draw this kind of word problem. So we have a lamppost, so we can draw the lamppost, and it casts a shadow of 18 feet. So I'm going to be casting some kind of shadow of 18 feet. 18 feet. When the angle of elevation of the sun, so it will go up, is 33.7 degrees. How high is the lamppost? So it's asking for the length or the height of the lamppost, so x. And now we have everything basically. So we have the opposite and we have the adjacent. We don't have hypotenuse, so we can use tangent. So tangent 33.7 degrees is going to be equal to opposite over adjacent, so x over 18. And we can find the height this way. So now we can just solve this. Now it's better to do it like this and rewrite it as x is equal to 18 times tangent 33.7. And as I mentioned at the beginning of the video, if you can also do it like this, tan 33, but you have to close the parentheses times 18. So we can do it on the calculator. We have x is equal to 18 times tangent 33.7. Then you do shift solve. You get 12. So x is equal to 12 feet. That's your answer. For the final question, we have a 12 feet ladder which is leaning against a house. So a ladder leaning against a house. So we have this house here. Then we have a ladder which is leaning against it. We'll draw it in pink. And it is 12 feet. And it makes an angle, a 64-degree angle with the ground. So it makes an angle with the ground, which is 64 feet. Angle right here. 64 degrees. Sorry. And it's asking us, will the ladder reach the window? So there's a there's some kind of window here that is 10.5, and this window is going to be 10.5 up from the house. 10.5 feet up from the house. And it's asking, will the ladder be tall enough to reach this window? So we want to find if the ladder will be tall enough to reach the window. So here we have another value of x, which tells us if the value will be tall enough to reach the window or not. So don't be mistaken. This 10.5 feet is for the window and not for the ladder. So it's like how far the window is from the ground of the house. So if like there's a window here in another house, it's asking, this gives us the value of 10.5 feet where the window is from the base. And it doesn't tell us whether how tall the ladder is. So to find a ladder, we need to find this length. We want to know whether or not it's going to be tall enough. And then we have opposite and we have hypotenuse. So we're going to use sine. So sine 64 give us opposite, which is x over 12. So x will be equal to 12 times sine 64. And then if we use it on the calculator, we write x, we don't have to write x, we just do 12 times sine 64, we get 10.7. 10.7. Is 10.7 greater than the height of the window? If yes, then it is the ladder will reach the house, and if it isn't, then the ladder will not. So this is how you know. If it's greater than 10.5, then it will be tall enough to reach the window, and if it's less than 10.5, then it will not be taller. That'll be it for lesson 5.2, right triangle trigonometry. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the server. And yeah, good luck.